Hello friends, I welcome you all on India's largest live e-learning educational platform, that is Gradeup. All the candidates who are joining me in this session, just tell me quickly whether my audio and visual quality is okay so that we can proceed. All the candidates who are joining me, just tell me quickly whether my audio and visual quality is okay so that we can proceed. Until you are reporting me about the audio and visual quality, let me just give you a brief idea what we are doing in this particular session, in this particular series, what we have achieved till now, and what we are going to achieve in this particular session. Friends, this is the fourth lecture in the series Startup 2.0, in which we will be discussing the concepts through questions. In the Startup 1, which is already available on the Gradeup GATE YouTube channel, you can follow the theoretical backup for the concepts of power system. It is already available. You can go to those sessions, those lectures to find the theoretical backup for these sessions. And in this series, we will be discussing number of questions, and through the questions, we will try to understand the concepts. Brahma Teja, how are you? Welcome to the session. Rajkumar Singh, welcome to the session. How are you? All the candidates who are joining me, just tell me quickly my audio and visual quality is okay. Can we proceed? Now, all the candidates who are watching me on this YouTube channel, Gradeup GATE YouTube channel, let me tell you friends, if you want the maximum benefit out of these sessions, then you have to follow the LSS method. What is LSS method? The LSS method is you have to like this video, subscribe this video, and share this video to your friends and colleagues so that maximum number of people, students, can be benefited out of this. Is it clear? Okay, we can proceed. So friends, today we are going to start the static compensation. Now some of you may not be aware with what is static compensation. So let me just tell you, it is about the voltage and power factor control, which we usually divide into static compensation, dynamic compensation, and solid state compensation. So today we will be discussing the static compensation. Is it clear to all of you? Okay. Now let us proceed with the session. Now some of you may be joining me for the first time, so let me just give you a brief introduction about myself. My name is Ashutosh Saxena. I have 10 plus years of teaching experience. I completed MTech from IIT BYJU'S in 2010. I have written a couple of books also on engineering ethics and power system. If you go and find the 2019 edition of engineering ethics book, which is already in market, you will find my name there. My areas of expertise are power system, electrical machines, electromagnetic field theory, material science, and engineering ethics. Saurabh, good evening. How are you? Welcome to the session. Now, friends, before we go to the exact topic, it is important that I usually discuss the candidate's name, which give me the correct answer on the YouTube, or the correct answer of the questions I give as homework on the Gradeup app doubt section. Both the candidates can answer these questions, and I will be taking the names. So for the previous lecture, that is the transient analysis, only one candidate has given me the answer to the previous question, and that is Jitendra Kumar. So a lot of congratulations to Jitendra Kumar. I hope if you keep on putting your hard work like that, definitely you will get the result. Good evening, Anuj Kumar, Racha, Bhavani. How are you? Welcome to the session. Welcome to the session. Hello, PK. How are you? Welcome to the session. Now friends, let us try to discuss the problems I have given as homework. I understand that many candidates, they are busy in watching the Facebook, in watching the YouTube, in watching so many bad things on the internet, but they do not find from their precious time to do questions like this and answer in the comment section. That is why I have to solve these questions in front of you, and you have to solve along with me. Is it clear? Now, very quickly, I will be answering these questions. Now, the first question I have given as homework, Kaja is saying D option. Yes, D is the correct option. Extra high voltage line of length 300 km can be approximated by a lossless line lossless line having the propagation constant beta like this, then the percentage ratio of the line length and the wavelength. What is the line length? L. What is the wavelength? Lambda. Line length is given as 300 kilometer. What is the wavelength? Wavelength you can write as 2 pi by beta. Is it clear? Brahma Teja, yes, you are right. 6.06 is the correct option. If you put the beta value here, you will be getting D option as the correct option. All of you just tell me, are you getting this answer or not? Can we proceed? Are you getting the answer to this question? Vaibhav, good evening. Welcome to the session. All the candidates on the Gradeup app and the YouTube, just tell me quickly, are you getting this answer? Can we proceed now? Can we proceed? Yes? Now let us go to the next question. Now the next question is, if the lightning stroke come to a surge, come with a surge current of 10 kilo ampere peak, then the transient over voltage is given as. Then the transient over voltage is given as. Listen. Now what you are having, suppose this is the situation. This is the situation. This is your transmission tower. Yes. And suppose this is the cross arm. This is the cross arm. And this is your insulator and this is your live conductor. This is your live conductor like this. Now he is saying when the lightning falls with IC is equal to 10 kilo ampere, IC is 10 kilo ampere, then what is the transient over voltage? Transient over voltage which may occur in the system. Suppose this is the point P. Now please try to understand very important point. With the lightning phenomena, you must be getting this, that the surge impedance is going to come into the picture, which is given as under root L by C, and it is independent of the length of the line. It is independent of the length of the line. Independent of the length of the line. So if it is independent of the length of the line, you can easily understand that if the current is hitting at point P, if the lightning is getting stuck at point P, to left and right of this lightning stroke, the surge impedance is independent of the length of the line. So wherever point it is going to strike, it is going to see the surge impedance at both the sides. So this current is going to be divided as IC by 2 and IC by 2. Now if you see, this is going to be grounding at the tower. At the tower it is going to be grounding. So what is going to happen, if you see at this point P, if the potential is Vp, how you can write the potential Vp? The potential Vp is going to be 1 by 2 Zc multiplied by 10 into 10 to the power 3 ampere. Is it clear? Now Zc value you have to take, you have to assume, because it is not given in the problem. So what is the standard value of Zc? Can you tell me? What is the standard value of Zc which you can take here? Tell me, all the candidates on YouTube and Gradeup app. What is the standard value of surge impedance for the transmission line you can take? Do you have any value? Do you remember? The standard value is 400 ohms. So you put Zc is equal to 400 ohms here, and you will be getting the transient over voltage which may occur in the system. Now all of you just tell me in the comment section, are you getting this idea or not? Are you comfortable? Yes, Rajkumar Singh, you are right. Are you comfortable? Can we proceed? चौहान MIT, बेटा मेगावाट में कैसे हो जाएगा? सर्ज इम्पीडेंस मेगावाट में होता है कि ओम्स में होता है? ओके, नाउ लेट अस गो टू द नेक्स्ट क्वेश्चन. A 400 kilometer long transmission line has phase constant of this much, and he is asking the length of the line in electrical radians. Now please try to understand. Please try to understand. Beta is defined as the radian per kilometer. So electrical length of the line, electrical length of the line is given as beta into L. What is beta? Yes, Brahma Teja, please wait. Beta is given as 0.00127 and kilometer is 400 kilometer length of the line. Just multiply this and you will get your answer. Beta L is defined as the electrical length of the line in radian. All of you just tell me, are you getting this idea or not? All the candidates who are watching me, just tell me, are you getting this idea or not? SH Khaja and Brahma Teja, I think your answer is correct. Is it clear? Now just see this question, very important question, previous year gate problem, very important question. Sunil Manjani is asking, sir, is the current, it's not the current, it is the lightning stroke, whether lightning, listen. One candidate, he is having a doubt, he is asking me, if the lightning strike at the middle of the line or anywhere else, because surge impedance is independent of the length of the line, so all the time it is going to be ZC only, whether it hits at the middle point or any other point. So you will be getting the same answer, approximately same answer. Are you getting this idea? Is it clear? Brahma Teja is giving 296 kilometer. Let us see whether his answer is correct or not. Everybody listen. Now for a long transmission line, you know that A is equal to cos hyperbolic gamma L. And if you know what is the series expansion of cos hyperbolic gamma L, you will understand it is 1 plus gamma L square upon factorial 2 plus gamma L raised to the power 4 upon factorial 4 plus higher orders. So for the approximate analysis of the line, if you ignore the higher order terms, you will get A is approximately equal to 1 plus gamma L square upon 2. Now he is saying that this is a lossless power transmission line. When it is a lossless power transmission line, it means what? Gamma is alpha plus j beta, where alpha represents the losses in the line, and this is called attenuation constant. It is called attenuation constant. So if you are saying it is a lossless line, so for the lossless line this is going to be 0. So you are saying gamma is equal to j beta. Just put gamma is equal to j beta in this equation and you will be getting A is equal to 1 minus beta square L square by 2. Is it clear to all of you? Are you getting this idea or not? Just tell me yes or no in the comment section. The people on the YouTube, you are not interacting. If you don't interact, you will not understand things. And very less number of people are watching on the YouTube. Please increase the number of counts. And I told you that if you want these type of lectures more and more, all the candidates follow this LSS method. Like this session, share this session in your friends group, friends, colleagues, social media groups, Facebook, WhatsApp, wherever you want to send, you can send. We want more and more students, then only we can have these type of sessions. We are putting a lot of efforts to bring to you these sessions. So you have to do your own part of effort. Yes. Now see, what is A? Please try to understand what is A. You are saying Vs is equal to AVR plus BIR. At no load, IR is going to be 0. No load means the load current or the receiving end current is 0. So you are getting Vs is equal to AVRO, and Vs and VRO values are given 400 volts and 420 volts. So it is going to be A is going to be 400 kilovolts upon 420 kilovolts. If you put this value, tell me what is the value of A you are getting. Tell me what is the value of A you are getting. Just put this value of A in this equation. 1 minus beta square L square by 2. And what is beta? Beta is omega upon V. What is V? V is under root LC, and this is nothing but C, that is the speed of light in the vacuum. So if you put omega is equal to 2 pi F, and this is C, C is given as 3 into 10 to the power 8 meter per second, and F is given as 50 hertz in the problem. You put all the values A here, F and C here, and you will get the value of L. Are you getting this? Everybody just tell me. Are you getting this idea or not? Tell me yes or no in the comment section. Are you comfortable? You can do this problem or not? Clear? Amal is saying 0.95. He is getting the value of A with this expression as 0.95. Just calculate what is the value of length of the transmission line you are getting. Just calculate what is the length of the transmission line you are getting. Calculate what is the length of the transmission line you are getting. Okay, leave it. I hope you can solve it. No problem with that. Now friends, before we go to the static compensation, some important information I want to share with all of you. We have just launched the Vision third batch for ESE and GATE aspirants, and we are offering right now 50% scholarship discount on the MRP to all the GATE qualified students, all IITs, NITs and other government engineering college students, ESE prelims qualified students. And if you want some more information, you can contact this number or this email ID. These are the faculties who are going to take classes in this particular course. All the faculties are very experienced and expertise in their particular subject. If you want to know the quality of content which we are providing you on the Gradeup in this particular course, classes have already started. You can go and start the free trial on the Gradeup app. You have to register yourself, and free of cost you can attend some classes to get to know how we are providing these classes to our students. Let us see some of the key highlights of this particular course. There is going to be 800 hours of live classes, 7,000 plus practice questions, study notes, full-length mock test, daily test and subject-wise test. And if you have any doubt, any query regarding this, you can contact this number, you can contact this email ID, or you can directly contact our course manager, that is Anand Pandey @gradeup.co. Is it clear to all of you? Clear? Okay. Listen. Now this is the first problem for the static compensation, and I want all of you to solve this problem and tell me the answer what you are getting. And if you are not comfortable with the static compensation, I can give you a brief introduction to static compensation. If you are comfortable, just do the problem directly. Let me just give you the figure for this particular question. Suppose this is the three-phase induction motor. This is the three-phase induction motor, and you are using a delta connected shunt capacitor bank to improve the power factor, and it is going to be something like this. Are you able to follow this question or not? This is the shunt capacitor bank, which is delta connected. All of you just tell me, are you comfortable with the static compensation or you want some input? I can give some input. If you are comfortable, just do this problem and tell me what is the answer you are getting. If you are not comfortable, I will start explaining the problem. Just tell me yes or no in the comment section. You want me to explain the problem or you want to do it on your own? You want me to explain the problem or you want to do it on your own? All the candidates on the Gradeup app and YouTube, just quickly tell me. At least respond to me. Otherwise, how we are going to communicate? Should I start the explanation? Tell me yes or no. Should I start the explanation? Tell me yes or no. You want me to solve the problem? Just tell me yes or no. Please explain. Okay. Listen. Listen very carefully. Listen very carefully. First, you have to understand. Suppose this is a system. This is a system. Suppose this is a load. And it is a lagging load. Lagging load means it consumes reactive power. So this is going to be P load plus JQ load. Just listen 1 or 2 minutes and you will understand the concept. Just listen 1 or 2 minutes and this problem is going to be a cakewalk for you forever, for all your professional life. Just listen 1 or 2 minutes. Very important. Suppose there is a load connected at the system. Okay. Suppose the current here is going to be IS1 and the current drawn by this load, suppose it is IL angle minus phi. Why I am saying minus phi? Because it is a lagging load. So the current is going to be lagging with this voltage. Suppose this is the receiving end voltage and this is the reference voltage. Everybody is okay with this? This is without compensation. This is without compensation. This is without compensation. Are you getting this idea or not? Now we are going to use the shunt capacitor bank. When you are using the shunt capacitor bank with shunt capacitor, what is the situation? Just tell me. With shunt capacitor, this is the line, this is the receiving end, this is the load. Now this load is IL angle minus phi and this is P load plus JQ load. And this is how you have connected the capacitor. Suppose this is the capacitor connected. Now for just one moment you listen my words. The moment you are connecting the shunt capacitor to the receiving end, what is the first thing which is going to change? You just visualize this thing in your mind. What is the first thing which is going to change the moment you are going to connect the shunt capacitor to the receiving end? What is the first thing which is going to change? Line current. Line current is going to become IS2. Are you getting this idea or not? Load current is not going to change because the receiving end voltage is like this. Load current is not changing. Load current you cannot change. What is changing? The current in the line. The line, supply line. Brahma Teja, perfect answer. Your answer is perfect. Listen. Other candidates, just listen to me. Now the line current is changing the first consequence. And what this capacitor is actually doing, it is going to supply the lagging reactive power to the system. Whenever you are going for shunt capacitor compensation or any capacitor, any compensation, you never say that the load power factor is changed. Load power factor you cannot change. You can vary the line current so you can change the system power factor. You cannot change the load power factor. Load power factor will remain same. Load power factor you cannot change. Yes, Jitendra, you are right. Your answer is correct. Now I'm going to ask you one thing. Suppose without compensation, from the sending end you were sending P1 and Q1, and with compensation you are sending P2 and Q2. The first thing is P1 is equal to P2 is equal to P load. What is the reason? The reason is when you are connecting the shunt capacitor to the receiving end, there is no real power exchange. This is a pure capacitor. Pure capacitor means there is no real power exchange. It means whatever requirement of real power is there at the receiving end because of the load, it is being supplied by the sending end. It is being supplied by the sending end. Now, initially without compensation, Q1 reactive power was supplied by the sending end. Now it is supplying Q2. So can I write Q1 minus Q2 is equal to Q shunt capacitor? I can write this thing or not? Because shunt capacitor is supplying some reactive power to the system. It means the burden of reactive power on the sending end is reduced. Initially it was Q1, now it is Q2. Are you getting this idea or not? Now if you go to the power triangle, how you are going to draw the power triangle? If this is real power, this is reactive power, this is the power factor angle, you can say. Can you write Q is equal to P tan phi? Yes or no? Can you write Q is equal to P tan phi? It means you can write the Q shunt capacitor as P tan phi 1 minus tan phi 2. It means if you know how the power factor is changing from phi 1 to phi 2, you can find the reactive power supplied by the capacitor. Vice versa. If you know the reactive power supplied by the capacitor, you can find the change in the power factor or the power factor angle. Yes or no? Just tell me in the comment section. Are you getting this idea or not? Are you getting this idea or not? Raja, Bhavani, please explain again. What explain again, beta? You always tell me exactly what is your doubt. Now just go to this problem. Just go to this problem and see what this problem is saying. This is saying induction motor is operating at this voltage and frequency. The rating of the induction motor is this much. This is the rating of the induction motor and it is the power factor. And this is the power factor. It means, can you tell me what is P load and what is Q load? Yes or no? Can you find the P load or Q load or not? Easily you can find. Now he is asking find the capacitance per phase of a delta connected shunt capacitor bank for improving the system power factor to 0.8 power factor. It means initially it was how much? It means you are saying cos phi 1 was 0.6 and cos phi 2 is 0.8. You find the values of phi 1 and phi 2 and put in this equation and put in this equation and put in this equation. Phi 1 is cos inverse 0.6 and phi 2 is cos inverse 0.8. Now what is the value of P? This is very important. What is the value of P? P is going to be P load and that is 4.5 because the motor rating is given. Motor rating is given as 4.5 kVA. So 4.5 cos phi. So multiplied by 0.6 you will be getting as 2.7 kilowatts. I hope you must be getting this. Just put this value of P here and you will be getting the reactive power. You will be getting the reactive power Q shunt capacitor. Reactive power supplied as 1.575 kVAR. This is the reactive power supplied by the capacitor. Are you getting this idea or not? Mamta Singham, your answer is not correct. Just check what is the mistake you are doing in your calculation. Everybody just getting this idea? The moment you get Q shunt capacitor, this is going to be 3 times V phase square upon XC. Get this idea or not? What is XC? XC is going to be 1 upon 2 pi FC, and this C is C per phase. So this Q shunt capacitor is going to be 3 times. Yes, Jiten Kumar, wait. It's okay if you got the answer. Understanding is more important for other students also. Listen. Now phase voltage is how much given? 400 volts multiplied by 2 pi, F is 50 and it is C per phase, capacitance per phase. Just calculate capacitance per phase and you will be getting the answer as 10.44 microfarad. All the candidates, just tell me in the comment section, are you getting this answer or not? Very important. This one problem is equivalent to 50 problems if you understand it logically, I can guarantee you. The concept I'm giving you, you can use this concept to solve 50 similar problems. Tell me quickly, are you getting this idea or not? Now is it clear? Everybody just tell me, are you getting this answer or not? And some people, they are not doing anything. They are just simply sitting like this and they are watching on mobile or laptop something and they are okay, we'll do one day. Just one day before the examination, we will do. All the videos of Ashutosh Sir, we will see just in one day and we will get selected. This is not going to happen. Forget Ashutosh Sir, no teacher, no mentor, nobody can help you if you are not doing the practice regularly. कुमावत अशोक बेटा हिंदी में क्या बताऊं? हिंदी में क्या बताऊं मैं आपको? पूछो क्या बताऊं हिंदी में? Now other candidates, just see this question and tell me, are you able to solve this? Other candidates, just see this question and tell me, are you able to follow this or not? Are you able to solve this problem? Just tell me quickly. Now other candidates, just listen. I can understand because you might be running out of patience. Just listen. Now he's saying the shunt reactor connected to the bus absorb 100 MVAR. It means Q absorbed 1 is going to be 100. Other candidates who are comfortable, please solve, and all other candidates who are not comfortable, just listen. Now he's saying 98% of the rated voltage and 96% of the rated frequency. It means what is the first thing you have to check? The first thing is you have to find how you can represent the reactive power absorbed by the shunt reactor. What is shunt reactor? Shunt reactor is going to be something like this. This is the load and you will be connecting the shunt reactor like this. So if this is the voltage at the receiving end, how you can write the reactive power absorbed? Jitendra Kumar is saying 100.04. Perfectly right. I think perfectly right answer. So this you will be writing 3 times V phase square upon XL. This is going to be XL. What is XL? XL is going to be 2 pi F into L. Pi F into L, and you can understand that Q absorbed is directly proportional to V square upon F. This is the relation you are getting for the reactive power absorbed. Brahma Teja is also correct. Correct answer. Only 2-3 candidates are working with me and rest candidates, they are just enjoying, not putting the hard work. If you want to compare the reactive power absorbed, the voltage and frequencies are changed, then it is going to be how much? It is going to be how much? This is going to be V2 upon V1 square, and this is going to be F1 upon F2. V2 you are going to put as 98%, so it is 0.98 V1, and F2 is going to be 96%, so this is going to be 0.96 F1. Just put these two values in this equation and just put QAB1 is equal to 100 MVAR. You will get the answer for QAB2 and you will get QAB2. I am writing the answer. 2 candidates have given the answer. Rest of you, please confirm this answer UAB2 you must be getting as 100.04 MVAR. 100.04 MVAR. Everybody just tell me, are you getting this or not? Tell me yes or no in the comment section. Are you getting this? Yes or no? Neither you are solving nor you are answering. How it can possible? How it can be possible? How it can be possible? If you are not interested, I will stop these classes. But I want response from you. If you want more number of classes, please interact. Please solve the problems. Otherwise, it is not going to be any use for you. See the next problem. Everybody just see the next problem. And tell me what is the answer you are getting. Are you able to solve this problem? Okay, all the candidates who are comfortable, just listen. Mamta Singham, right answer, beta. Now, all candidates who are comfortable, just try to solve this problem. Who are not comfortable, just listen to me how to approach this problem. He is saying a lossless transmission line has a surge impedance loading of 2280. For series capacitor compensation of 30%, the surge impedance loading will be. First, you have to understand that your transmission line is something like this. The transmission line is something like this. You can represent your line like this, yes or no? Suppose this is X line, okay, and this is B line. Brahma Teja is saying 1248.8. Brahma Teja, this time incorrect answer, beta, incorrect answer. Just listen. Understand. If you are not comfortable, just listen. How you are going to define 2725.12? Jiten Kumar, perfect answer. Jitendra, perfect answer. Listen. How you are going to define the surge impedance? Surge impedance you are going to define as under root L by C. This you can write as J omega L. Forget about J. You can simply write as omega L upon omega C. Omega L upon omega C. So you can write it as X line upon B line. Now in the next part he is saying a 30% series capacitor compensation is there. What is the meaning of 30% series capacitor compensation? This is the line reactance. You are putting a series capacitor and this is the line shunt capacitance. This is X line, this is JX line, and this is going to be minus JXC. Why minus? Because the reactance you are writing for the capacitor, so it is going to be negative. And this is B line. This is B line. So if you want to write ZC2, then it is going to be X line minus XC upon B line. Now you are saying 30% series capacitor compensation. It means by putting the series capacitor, 30% of the line reactance you are compensating. It means what? X line minus XC you are getting as 0.7 X line, because 30% you have compensated. So what is the remaining reactance? Remaining reactance is 1 minus 0.3, that is 0.7 X line. So my friend, very effectively you can write ZC2 as 0.7 X line upon B line. Now can you compare the surge impedance loading? Yes, surge impedance loading is defined as V square upon ZC. So both the cases, if you want to compare surge impedance loading 2 and surge impedance loading 1, this is going to be ZC1 upon ZC2. What is ZC1? ZC1 is going to be X line upon B line, and this is going to be 1 upon ZC2, so this is going to be B line, and this is going to be 0.7 X line. Surge impedance loading 2 is going to be surge impedance loading 1, that is 2280 divided by under root 0.7. Just solve this value and you will be getting somewhere around 2725.12 megawatts. Everybody just tell me, are you able to follow this or not? Are you able to follow this or not? Just tell me, everyone. Mamta Singham, Racha, Bhavani, Amal, all the candidates who are watching me on Gradeup app, are you getting this idea or not? Just tell me quickly. Are you sleeping? Jagat, JP and Jiten Kumar both have given the correct answer. What about other candidates? Are you able to follow this or not? Now friends, this question I want to give you as part of your homework. This is your homework 1. Just solve this problem. Both the candidates, people who are watching me on YouTube, solve this problem and give me the answer to this question in the comment section of this YouTube video. And all the candidates who are watching me on the Gradeup app, you give your answer through the doubt section of the Gradeup app. I will be taking your name into the wall of fame in tomorrow's class. Okay. This is the first problem, first homework problem, and this is the second homework problem. Just quickly take the images. And all the candidates who are watching me on YouTube, even if you are watching it, the recorded video, all the candidates, if you want the best of these classes, you have to follow this method. Do you remember what is this method? Like, share, subscribe. Don't forget to like, share and subscribe. Okay. So friends, now we are going to stop here with this, and some more important information I wanted to give you. Just wait, I will give you important information. Right now we are offering you 40% scholarship discount on the MRP for the recently launched Score Up SSC JEE crash course for paper 1 to all the government engineering college students, including diploma students, SSC JEE paper 1 qualified students. And for more information, you can contact these numbers. These are the faculties who are going to take classes in this particular course. Manoj Singh sir, Vijay Bansal sir, Neha Joshi ma'am, Zubair Ahsani sir. So if you want to experience the change Gradeup is bringing to the life of thousands of students, you must start the free trial. Classes have already started free of cost. You can attend some of the classes. Let us see some of the key highlights of this particular Score Up SSC JEE crash course. It is a 60-day crash course. The exam is going to be conducted on 1st to 4th September. You must be having this date. 200 hours of live classes, 5,000 plus questions in the live classes we are going to provide you. 2,000 plus practice questions, study notes covering each topic, 20 subject wise and 10 full length mock tests, daily test and weekly test. And if you have any query, you can contact this number or these email IDs and you will be assisted in the best possible way. Okay friends, last but not the least, with all the proud, I want to share this information to all of you that there are 60 plus Gradeup students in the top 100 merit list of the GATE 2020 examination. So if you want yourself to be in this panel next year 2021, my friend, whether it is GATE, engineering services or any other examination of your choice, my friend, you have to do 2 things. And all my old students know what are these 2 things. Number 1, it is hard work. Number 2, it is hard work. Harsha CVS is saying I am from ECE, but Gradeup is providing excellent concept. Sir, thank you very much. Thank you so much, Harsha, for your appreciation. But I am not satisfied with your appreciation. I will be satisfied when more and more students are going to come to the live class and everybody get benefited out of these sessions on which we are putting lot of efforts, and all the candidates who are watching me on the YouTube, if you want more good quality content, more you can say ways to prepare for your examination, lot more quizzes, lot more content, everything, if you want, you have to come to the Gradeup app from the YouTube. That is very, very important. So thank you so much for your time. I wish you all the best. Take care of yourself. Stay safe. Stay in your home. Follow the government regulations. Don't go outside. And don't forget to join me again tomorrow 8 p.m. I will be bringing to you some more interesting concepts and questions under this series Startup 2.0. So see you again tomorrow 8 p.m. Take care of yourself. Prep smart. Score better. Go Gradeup. Thank you so much.